Here's the too long and you didn't watch version. This flat line isn't fraud. This is what simulated fraud looks like. This is what simulated non-fraud looks like. Using some basic math and statements about fair elections, you can model what a fair election looks like, though you don't have to watch if you don't want to. Here's what several fair elections look like. Using the model, it's obvious that this election data that Dr.SHIVA says looks normal does in fact look normal. But so does this data that he says is abnormal. One set of data does look a little strange, though I'm not sure why, and by the way, the plot in his second video doesn't detect fraud any better. Before we get into the details, let's take a quick peek at what's coming. We're going to start with a little bit about Dr.SHIVA, and I hope I say this correctly, Ayyadurai, and what he got right in his analysis. I don't want to butcher his last name, so I'll just call him Dr.SHIVA from now on. We'll talk about what he claims in his first video, understand how he went about creating his graph, and why you should be suspicious of his claims. Then we'll talk about where I think his analysis went wrong, and create a model of what at least some fair elections look like. The model will show us that the features Dr.SHIVA calls abnormal are in fact just fine. We'll compare that model to real-world data. We'll simulate the kind of fraud Dr.SHIVA and others allege took place to see what it would look like on his plot. We'll briefly cover the plot in his second video, and finally we'll talk about where to go from here. I want to state right off the bat that Dr.SHIVA is a smart man with a PhD from the Massachusetts Institute of Technology. And if you've seen comments around the web calling him a fraud for saying he's the inventor of email, you should ignore them for the most part. The truth is far more nuanced than that. In 1971, ARPANET engineer Ray Tomlinson, who also happens to be an MIT graduate, created the user@host email identifier that we all use today. He also wrote the first program to send electronic messages over ARPANET, the predecessor to the Internet, with a pair of programs called SendMessage and ReadMail. Because of that, many people consider him to be the inventor of email. But Tomlinson's programs weren't like the email programs we have today. You had to send your messages directly to the computer of the user you were writing to, and that's not at all how email works today. In 1979, Dr.SHIVA wrote the first mail server program, which he called email. It was the first program that allowed email to be stored on a server, where it could then be retrieved by the user from anywhere else in the world. That's the predecessor to today's modern SMTP mail servers and webmail services like Gmail that we use today. It's really a shame that Dr.SHIVA tries to claim the mantle of sole inventor of email for himself, because I think it lessens the credibility of his actually very important contributions to the Internet. That's Dr.SHIVA. What about me? Well, I have a degree in engineering physics from Cornell University, but beside that, I'm not anybody particularly important. And while I'm here to argue against Dr.SHIVA's election analysis, I don't think everything he says is wrong. He's absolutely right when he says that our elections are not transparent enough. He's right to say that fraud is possible. He's right to say that fraud has happened in the past, and he's right to say that people will cheat if they think they can get away with it. So we should all care about election transparency and integrity. But having said that, you can't just go around calling elections fraudulent without extraordinary proof. So what exactly does Dr.SHIVA claim in his videos? In his first video, he introduces a scatter plot that he says can be used for feature extraction. And without any evidence, he claims that we should expect the ratio of Trump to Biden votes on split tickets to be close to the ratio of Trump to Biden votes on straight party tickets. And using his math, if an election works out to be that way, you'll get roughly a straight and flat plot. In his second video, he backtracks on that a little bit, but then introduces another supposedly feature-extracting plot created by an associate of his that shows the number of split-ticket votes versus straight-ticket votes for each party. He also claims that the weighted vote function of election machines was probably used to cheat in the 2020 election. So let's dive right into this plot head-on. It's based on raw election data that can be broken into 4 voter populations: the number of straight-ticket votes cast for Biden and Trump, and the number of split-ticket votes cast for Biden and Trump. This particular chart wasn't drawn by Dr.SHIVA. I created it to help visualize the voting populations in each district. Each chart has the same x-axis as Dr.SHIVA's scatter plots, and each chart represents exactly one of many possible fair elections. The chart can't tell you who wins or loses all by itself. It just tells you what the expected voting percentages are for a given district. Each district is going to show up as a dot somewhere on the chart, like this. Where it is located horizontally is supposed to tell you something about how conservative that district is. So, for instance, let's suppose this district had only Democrats in it. And it would be placed somewhere over here on the left edge of the plot. If we look along the y-axis where the district is located, you can see that we expect about half of everybody that votes in this district to cast a Democratic straight ticket, and nobody to cast a Republican straight ticket. On the other hand, if the district had only Republicans in it, like this, we'll need to move it over here, to the right side. Looking up, we see the opposite of what we saw before. Now half of everybody that votes in this district will cast a Republican straight ticket, and nobody casts a Democrat straight ticket. Votes above this purple line are all for Biden, and votes below it are all for Trump. So on this particular plot, if all the districts are on the left half of the graph like this, then Biden wins because every district has more votes for Biden than for Trump. On the other hand, if all the districts are on the right half of the plot like this, then all of the districts would have more votes for Trump than Biden, so Trump would win. To better understand how Dr. Shiva came up with his graph, let's listen to what he has to say about it himself. We'll start with how he decided where the districts should go along the x-axis.
Now, there's two types of voting at a precinct, and here's an example. So let's say 200 total voters go to a precinct. Okay, so 200 people walk into that precinct. Let's say 100 of them decide to vote the straight party method. And let's say the votes happen to be 60 votes for Republican candidates and 40 votes for Democrat candidates. So that would be 60% R, 40% D. So that you could argue that that precinct of voters who chose to do the straight party method, it's an indicator of the demographics that that precinct is probably likely a Republican.
Okay, now let's take a look at the y-axis. We'll have to do this in two steps. First, we have to find the percent of split party votes for Trump. Here's what he says about that.
The other 100 voters who didn't want to do the straight party voting, they chose to do individual candidates. And in this case, we're looking at, let's say 65 votes went for Trump, and let's say 35 votes went for Biden. So that you'd have on the individual candidates percentages, 65% Trump, 35% Biden.
Finally, we can combine both pieces of information to get the y-axis. Let's listen to him describe that.
Again, to be clear, on the x-axis, we're going to have Republican straight party vote percentages, right? And on the y-axis, we're going to have the difference between the percentage of people who voted for Trump in the individual candidates vote minus the people who voted straight Republican percentage votes. And this will get clear.
So the upshot of all this is that because Dr. Shiva expects the ratio of split ticket votes cast for Biden and Trump to be roughly the same as the ratio of straight ticket votes cast for Biden and Trump, he subtracts them from each other and says that on average you'd expect to get something close to zero. And if Trump gets more split party votes than expected, the district will appear further up, just like in the example Dr. Shiva gave in his video. On the other hand, if Trump gets fewer split party votes than expected, the dot will appear further down. So his original idea was this: plot a whole bunch of districts, and if the election is fair, you should see something that resembles a flat horizontal line. But as we'll soon see, the idea that these dots should always hover around zero is wrong. I want to convince you right away that you should be at least a little suspicious of what Dr. Shiva claims. In his first video, he says that his plot should look like a flat horizontal line, and that's what we've already discussed. Let's listen to Dr. Shiva describe that for himself.
So just to be clear, every blue dot is a precinct. So in the normal case, if you look at this, if the center line, the red line, is Republicans, okay, straight line, because the reality is that anyone who voted Republican probably voted for Trump. So if you look at all these precincts, they should hover around zero, right?
But if we watch Dr. Shiva's second video, he abruptly reverses course and says that the normal case is a parabolic curve. Well, let's watch him describe that.
We're going to look at the normal state and the abnormal state. Remember, we need to know the normal state. So how do we get this? So look, here's what it should look like. You should get this parabola. And this is Jefferson County.
So 2 videos, 2 claims. Which is it? Flat line or parabolic curve? Well, of course, people make mistakes. With the first model I created to look into Dr. Shiva's claims, I accidentally used the wrong independent variable on the x-axis, so if you look around the net, you might actually find that. I fixed it, and I admit I made that mistake. Fixing errors is what you're supposed to do. So should we give Dr. Shiva a pass on that? Well, not so fast. I would if Dr. Shiva had readily admitted that he made a mistake, but in his second video he seems to double down on this erroneous gut-feeling feature prediction rather than admit he jumped to conclusions. And don't buy the idea that Dr. Shiva always thought that this line thing should have been a parabola. The whole reason he put the minus x term into his equation was because he was expecting to get a flat horizontal line by putting it there. So, which of his videos was right? Neither, actually, and you'll see that for yourself by the end of the video. So, what went wrong? In my opinion, Dr. Shiva's first video is a classic example of how not to do a science fair project. I imagine the inner dialogue Dr. Shiva had with himself probably went something like this. He's thinking, Trump lost. I think there must have been some fraud in the 2020 election. Then he thinks to himself, how can I prove it? Well, the percent of independent voters that vote for Trump should roughly equal the percent of straight-ticket voters that vote for Trump in a fair election. So I'll use the raw data from this unfair 2020 election to create scatter plots. I'll subtract one value from the other for the y-axis, and if the result isn't flat, I'll know my observation was correct. Then he does some quick Excel magic and thinks to himself, aha, dear Watson, the plots aren't flat, so there must be fraud. But if that was what he was thinking, then there are several problems. First, saying that you think there is fraud isn't an observation of fact. It's just an opinion in search of validation. And his hypothesis, which he never really outright states, isn't a hypothesis. It's just a gut-feeling guess. This hypothesis doesn't even really address the original observation. Even if it were the case that a normal election produces a flat line on his plot, it might turn out that an abnormal election also produces a flat line on his plot. So the hypothesis doesn't even set out to verify the observation that he made. Then, after he makes this claim, he uses data that he already thinks came from a fraudulent election. And you can't check to see if a fair election test that you've created works unless you feed it data from an election you know is fair. On top of that, he only uses a few sets of data, not nearly enough to draw serious conclusions about his hypothesis. And finally, he jumps to the conclusion that if his expected plot doesn't appear, there must have been fraud, when the normal scientific method thing to do would be to say your hypothesis isn't proven, so you should revise it and try again. So I'm going to try to do a better job of analyzing this data than Dr. Shiva did. Now, I readily admit that I'm not an expert in this field, but neither is Dr. Shiva. His degree is in bioengineering, not statistical analysis or political science. This is going to be my approach. I'm going to make some observations, create a hypothesis, create a way to test that hypothesis, and then test it against raw data. Then I'll draw some conclusions. Let's start with observation. Of course, I want to critique Dr. Shiva's analysis specifically, so I'm going to restrict myself to using the same equations and data that he used. First, it's impossible for me to figure out what a fair election looks like using raw data if I'm not even sure that that raw data comes from a fair election in the first place. Similarly, I can't say anything about what an unfair election looks like if I don't have a source of data from an election that I know is unfair, and I'm not even sure if an unfair election will look any different than a fair election using Dr. Shiva's equation. But Dr. Shiva's original idea has some merit. It's quite possible that everyone living in a county will all statistically vote similarly to each other. After all, people living in the same area all share the same news source. They share the same governor. They all have similar life experiences. So even though they live in different voting districts, it's quite possible that the same percentages of people will vote the same way from district to district. If we can find a way to model this behavior in a simple but objectively fair way, we should be able to apply Dr. Shiva to that model and see what a simplified fair election would look like. Our model doesn't even have to predict a winner, since we're only interested in predicting how districts might vote depending on how conservative they are. That way it doesn't favor one party over the other. Now, let's take a look at our source of data. Recall first that the data we get from elections is broken up into 4 groups. But in reality, there are 6 groups of voters, not 4. This is because the pool of split-ticket voters can be broken up into Democrats who split their tickets and Republicans who split their tickets. And there's no reason to assume that just because Republicans split their tickets, that Democrats will split them as well. It's going to turn out that this idea is precisely why Dr. Shiva's plots all fail to work as he expects. So, on to my hypothesis. Applying Dr. Shiva's equation to a simplistic but fair election model will allow us to gain insight into both Dr. Shiva's equation and the raw data that he used. Now we're ready to devise a model, and I apologize, but like most of science, we're going to need some algebra to do this. We'll start by naming some variables so we can use them while we think up rules for our model. The variable names are all going to be similar to each other. I'm going to use fractions instead of percents because they're easier to work with mathematically. To get from percent to a fraction, you just divide by 100, so they're basically the same anyway. Each variable will represent a fraction of some whole amount. Sometimes that whole amount will be all the votes, and sometimes not. The abbreviations will all look like this. The first letter or few letters in front will tell you what the whole part of the fraction is from. The next few letters will tell you what portion of the whole the fraction represents. So as an example, the A in front of this variable lets you know that this is a fraction of all votes, and specifically that it's the portion of all votes made up by Republicans on a split ticket cast for Trump. This chart shows all the votes at once, so we can see that on the right edge of this graph, it looks like the portion of votes for ARSPT is roughly a third of the whole. So that variable would be equal to about 0.3 when x is equal to 100%. Okay, now that we've named our variables, now we're going to devise some rules for our model, and these are really pretty easy to follow. First, we're going to say that there are no third-party shenanigans. We don't want to have to think about how Joe Jorgensen might affect things in our election. Remember, we're not interested in predicting exactly how things really happened. We just want to get a general feeling for what a fair election looks like on Dr. Shiva's plots. So we're going to require that there are only 2 candidates. There are only 2 parties. There are no independents, no write-ins, no registered Democrats voting a Republican straight ticket, no registered Republicans voting a Democrat straight ticket, and all participants in the election are going to vote exactly once for every office that they are able to. Next, we'll say that the fraction of Republicans that split their vote will be a constant in all districts. Note that this idea is very similar to Dr. Shiva's, except we're breaking the percentage of people who cast a split ticket into 2 groups instead of 1. The equation to calculate this fraction is pretty simple. It's just the number of Republicans who split their ticket either for Trump or Biden, divided by the total of all Republican votes. If you're observant, you might notice that the variables in this equation represent fractions, not votes, but that's because all you have to do to get from a fraction of all votes to the actual number of votes is to multiply by the total number of votes cast. But if you do that, you'll see that the total number of votes cast cancels everywhere, so we don't really need it. Next, we'll say that the fraction of Republicans who cast split tickets for Biden will also be a constant. Note that this is a fraction of a fraction. If this variable is 0.5, we're not saying that half of all Republicans vote for Biden. We're saying that half of all Republicans that split their vote did. That fraction is also easy to calculate. It's just the number of Republicans who cast a split vote for Biden divided by the total number of Republican split votes for both Biden and Trump. Then, because we're being perfectly fair, we'll do the exact same thing for the Democrats, except down here we have a fraction of how many Democrats vote for Trump instead of for Biden. And that's it. Those are the rules. They're all very similar to the ideas that Dr. Shiva started with, but that won't be quite enough information for us. We'll need just a couple more facts. First, the 6 fractions that represent all voting populations have to add up to 1. That's just because when we add everybody up, they have to represent 100% of all the people who voted. Next, we already know the fraction of all straight ticket votes cast for the GOP. That's because that's how the x-axis was defined by Dr. Shiva, so we'll just write that down. It's the number of straight ticket Republican votes divided by all straight ticket votes. And Finally, we're going to use the same Y equation that Dr. Shiva used, which is just the fraction of split-ticket votes for Trump, this time adding the Democrat and Republican portions together to get that number, divided by all the split-ticket votes cast minus X. Before we go on, I really want to hammer home a point that confuses some people. The percent of split votes doesn't tell you how many people vote for the other side's president. You could have 100% of all Republicans cast a split ticket, but if they did that only so they could vote for a Democratic water board member, then they'd all still be voting for Trump. Likewise, the percent of Republican split votes that are cast for Biden doesn't tell you how many Republicans voted for Biden either, because even if 100% of Republicans who split their vote end up voting for Biden, but there are no Republicans who actually split their vote, all Republicans must have voted a straight ticket for the GOP. In short, a high percent split vote rate does not tell you how many people voted for the other side's president. A high flip vote rate does not tell you how many people voted for the other side's president. Only the product of the two tells you what fraction of people vote for the other side's president. Now we have to solve the equations that we have written down, and I'll warn you, here is where things get a little messy. We have 6 independent equations and 6 unknowns, and if you remember your algebra, you'll recall that this is enough information to solve these equations. If you're a glutton for punishment, you can try to work these out by hand, but I'm just not, so I'm going to use an online solver. If you hate math, now is the time to close your eyes. First, we have to make a quick variable substitution. Computer solvers like single-letter variables. So I just replaced the variables in this equation using this map. Once you do that, you get this set of equations over here, and you can easily plug them into any online solver. Once you do that, you'll get this. That's some nasty-looking algebra. But remember, it just comes out of basic rules we wrote down earlier. Now we just need to switch the one-letter variable names back to the original variable names, and you'll get that. Now that we've got some lovely equations, we need to plot them. And I'm not going to walk you through that. You can do it on your own if you're interested. Instead, I've created an online resource where that's already been done for you. Just go to modelingdrshiva.com. Now, you may run into older versions of this model on the net, but if you go to that address, you'll always get the latest version. We're going to explore the model we created. Remember, it's not intended to perfectly replicate the real world, just show hypothetical outcomes from hypothetically fair elections. Nobody is cheating in these elections. Before we go on, I'm going to quickly remind you that the plots don't tell you who wins. They only show you how a district is expected to vote. To know who actually wins, you have to know how many Republicans and Democrats vote in every district. How many people live in each of those little dots isn't shown, so even though it looks like a Biden win on the left side and a Trump win on the right, if that single little dot has more votes in it than all the other districts combined, Trump would win on the left and Biden would win on the right. The point I want to drive home here is that these plots are utterly fair because they don't talk about who is doing the voting or who is winning. They only predict how people will vote once you know how many Republicans and Democrats live in each district. Here's our first model plot. Suppose only a few people on the Republican side vote a split ticket for a Democrat city dog catcher candidate. But when they do, they still vote for Trump for president. The Democrats don't split any tickets, so all Republicans vote for Trump and all Democrats vote for Biden. This is a very straightforward election. If this were to happen, Dr. Shiva's scatter plot would follow this 45-degree line that runs from 100% on the left all the way down to 0% on the right. Notice it's not flat, it's not curved, but it's utterly fair. Whichever side has the larger turnout wins the presidency. So why does this happen? It's because 100% of all split votes cast go to Trump, and 100% minus X is this line. Now let's tweak this just a little bit and ask what happens if a few people on both sides split their vote. Now, some of the Democrats are voting for a Republican candidate for the city's important cat catcher office. Everybody still votes for their own party's presidential candidate, though. Dr. Shiva's plot has now become a flat horizontal line on the x-axis, exactly what he predicted in his first video. Why? Well, it's because the fraction of split votes cast for Trump is exactly equal to the fraction of Republicans who cast straight ticket votes. X minus X is 0, so we get a flat line. Okay, now let's say that the Republicans don't want to vote for the Democrat city dog catcher anymore, so they all vote straight ticket, while the Democrats continue to split their vote. Still, everyone is voting for their own president. Now, none of the split tickets are cast for Trump, and our equation becomes 0 minus X, a 45-degree line that has shifted down by 100%. In all three examples, these outcomes are identical and fair. The winner is always the party with the better turnout. If there are more Republicans, Trump wins, and if there are more Democrats, Biden wins. And I hope you agree that you can't get any more fair than that. Yet, all three plots are different. One is flat, two are sloped, but each of the sloped plots is at a different place vertically. Clearly, the slope and location of the line don't tell you anything about the fairness of an election. Well, what if everybody were to vote for Trump? Suppose Scooby-Doo comes along and pulls a face mask off of Biden. Underneath is a criminal mastermind. Come on, folks. I would have gotten away with it if it weren't for these meddling kids. This is one of the two special cases that I mentioned earlier. This is the absolute best case scenario for Trump. No matter how liberal each district is, Trump always wins. But look at Dr. Shiva's plot. It's a perfect 45-degree line, the exact same one we saw earlier. Why? Because 100% of all votes were cast for Trump, just like in the first graph we looked at. No district can ever appear on Dr. Shiva's plot any higher than this line. So, a quick note. Why aren't there any straight ticket votes on this graph? Well, it's just a mathematical fluke caused by the choice of independent variable that Dr. Shiva made. There's just no room left to represent straight ticket voters along the x-axis. Suppose you have a county-wide election with 10,000 Democrats, but only one of them casts a straight ticket. According to this graph, if a district happens to contain that one straight ticket Democrat voter, if the district is anywhere below 50%, there can't be any straight ticket Republicans at all. If it happened to appear in the middle of the graph, there'd be exactly one straight ticket Republican, because if there's one straight ticket Republican and one straight ticket Democrat, then 50% of all straight ticket voters are Republican. At 75%, there would be 3 straight ticket Republicans. At 90%, there would be 9 straight ticket Republicans. And at 99%, there would be 99 straight ticket Republicans. And we already knew that there were no split ticket Republicans. End result, the entire graph only shows those 9,999 split ticket Democrat voters. Now, this doesn't mean that there aren't any Republicans at all. It's just that their districts are all going to appear on the far right side of the plot. If that one straight ticket Democrat happens to live in a district all by himself, his district will be the only one on the left side, and it will appear exactly at x equals 0%. But if he doesn't live all by himself, then his Republican straight ticket voting neighbors are going to cause his district to appear somewhere over on the right side, probably close to 100%, assuming that there are more than 10 of them. Every other district is going to have a 100% Republican straight ticket voting rate, so they'll all appear on the right side somewhere on this vertical line. What about the other special case, where everybody votes for Biden? Scooby-Doo is fake news, everybody. I'm not really a criminal mastermind. No matter how Republican the districts are, now Biden always wins. It's the worst possible case for Trump, and we can see that no district can appear on Dr. Shiva's plot any lower than this 45-degree line. What if it's a perfect 50-50 split? Well, we still get a 45-degree line, but it's halfway between the other two extremes. So why are we seeing so many plots with this downward slope? Also, so far all our examples have been straight lines. Are they all going to be straight lines? Well, we shouldn't be surprised that all the plots slope downward. Subtracting x does exactly that. The original data is a percent that ranges from 0 to 100% on both axes, and if you subtract x, that's just like shearing the box downward. It's the same data, just presented in a new shape. So what about the fact that they've all been straight so far? Well, that happens under 3 very specific conditions. First, when one of the two parties doesn't cast any split votes. in that case, that party can't influence how many split votes were cast for Trump. The second case is when one of the parties always splits their vote. That's because, as we saw just a few slides ago, if one of the parties splits all their votes, there isn't any room left on the plot for the other side. Even though they do influence the number of votes cast for Trump, it doesn't show up anywhere and we can't see it. Finally, if the percent of Republicans who split their vote is exactly equal to the percent of Democrats who split their vote, you'll also get a straight line. How about when these conditions aren't met? Curves! You get lots of curves. In this example, almost everybody splits their vote, but only a few people vote for the other side's president. And I'm going to let you in on a little secret too. I didn't choose these numbers at random. Does that look like Dr.SHIVA's normal scatter plot example? Why, yes, it does. What do you think? Can we fit Dr.SHIVA's supposedly abnormal case using our model too? Oh, we sure can. Okay, in fact, you can actually get a lot of different shapes for the model. But there are rules. They are all either straight, concave down, or concave up. And they never switch from being concave down to concave up, or vice versa. So now we're ready to test our hypothesis and model against real-world data. You can do this yourself in the modeler if you scroll down to the bottom. There you'll find a section with raw data in it. This example is from Oakland County's absentee vote. You can click the little circles, and when you do, the respective data will turn on. There are 6 plots on these graphs, not 1. The 3 scatter plots with dots are raw data from the 2020 election. The 3 lines represent the predictions made by our model. The green dots and line show the percentage of split votes cast in each district. The green dots aren't broken up by party, it's just the total percent of split votes, exactly like it appears in the raw election data. The black dots and line represent Dr.SHIVA's scatter plot, and the purple dots and line are Dr.SHIVA's plot, but without the -x term and shifted up so it's not in the way. There are 4 parameters you can adjust. The first 2, the percent of Democrats or Republicans that vote a split ticket, can cause all the lines to move when you change their values. The bottom 2 parameters, the percent of Democrat or Republican split ticket voters that flip to the other side's candidate, will only move the black and purple lines. There's no automatic data fit capability built into the modeler, but there is an R² display for the black and green lines. Before you start fitting raw data, you'll need to change which table is being used to calculate the R² values. First, look at the table of data you're displaying and make a note of the table number. Here, it's 6. Next, put that table number here, 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 and here in the R² calculator lines near the top of the window. Then you can maximize R² by adjusting the parameters, and when you're done, if you want, you can display the residuals by clicking these plot buttons. Okay, here's our very first result. It's for Oakland County's absentee vote. You can clearly see that most of the data follow the 2 prediction lines. Our R² values are 0.444 and 0.2917. To me, this looks like a pretty decent fit, but I want to make it clear that just like Dr.SHIVA's failure to get what he expected didn't mean that the election was fraudulent. It only shows us that the general plot shape is normal. Here's Oakland County's in-person result. Of all the data I managed to collect and put into the model, this is the one with the poorest fit. The green scatter plot is kind of all over the place compared to where you'd expect it to be. A lot of the districts fall way off the line, but I have a few things to note about this. First, notice that many of the districts are clustered on the right side of the graph, and that the percentage of split votes is very high for both parties. Remember that when the split vote rate is high, the x-axis starts to do a bad job of showing us how conservative a district is. Also, we don't know how many people live in these districts that are scattered away from the line. If only a handful of people live in each one of these districts, then the result isn't as surprising as it would be if 1,000 people lived in each one of them. Okay, here's Kent County. It has a pretty good fit. Here's Macomb absentee. It has the best fit of any of the data that I checked. This is Macomb's in-person vote. It also fits pretty well. So now that we've looked at the raw data and seen that it all pretty much looks like what our model predicted, we've pretty much cast Dr.SHIVA's fraud features out the window. But does that mean that we can't see fraud using the plot? Well, we haven't shown that at all. So now let's try to create a real map of what fraud would look like. We're going to do that by taking a county with a very good fit to our fair model election prediction, assume that it is fair, and then intentionally introduce simulated fraud and see what happens to the plot. Each one of these rectangles is going to demonstrate a different sort of fraud. Each vertical pair is the same type of fraud, with the top rectangle directed at Biden and the bottom rectangle directed at Trump. From left to right, we have uncounted straight and split ticket votes, split ticket dumping. Split ticket dumping for Biden is the kind of fraud that has been repeatedly alleged on the internet. Straight ticket dumping, voting machines set to undercount votes, and voting machines set to overcount votes. You can see right away that the real fraud features we should be looking for aren't anything like what Dr.SHIVA has claimed in his videos. Fraud doesn't show up in the general shape of the plots, rather it shows up as affected districts moving away from their unaffected counterparts in predictable ways. Before we get too carried away with this analysis, it's important to remember that even though we've shown fraud definitely moves dots around in a predictable way, not every moved dot necessarily means fraud has been committed. As an example, let's ask what happens if one party has a candidate on the ticket that's just utterly unelectable for some reason. Or maybe there's just a whole lot of non-presidential and non-congressional offices on the ticket. When this happens, the party will end up casting more split tickets than they might otherwise have done. I call these votes dog catcher votes because the ballots are being split over relatively unimportant offices when compared to the presidency or congressional offices. Of course, it isn't fraud when this happens, but we need to see what it looks like. It's also important to point out that these dog catcher votes don't alter the outcome of the election for president at all, because when people cast these votes, they're still voting for their own party's president. I've also included USPS delivery failure, which affects both parties at the same time. On the far left, we have USPS delivery rate, which normally would be 100% or all ballots delivered on time. In the middle, we have Democrat dog catcher votes, and on the right, Republican dog catcher votes. Notice that the USPS delivery chart isn't changing at all. That's because both parties are being scaled equally negatively, and the two cancel each other out. Let's make a feature map of all the charts we've produced, except for the USPS delivery chart. If a large number, but not all districts are affected by fraud, and if the level of fraud is sufficient, it certainly seems possible to detect some kinds of fraud in an election. When a single party's votes aren't counted, the districts pop out in all directions to one side. Dumping split votes causes the districts to move vertically. Straight ticket dumping causes diagonal movement, and scaling causes districts to move in curved trajectories. Underscaling for one candidate looks very similar to overscaling for the other. So now that I've exhausted my examination of Dr. Shiva's equation, I want to take another look at that minus x term he used. As we saw earlier, all it does is shear the graph down. But what do all these graphs look like if we don't subtract x? Well, I made two more videos, exactly like before, only now there's no minus x term. Instead, I'm adding 100% so the two plots aren't right on top of each other. Note that because I'm adding something instead of subtracting it, the two plots have switched places. Now it's the lower plot that tells us how many people split vote, and the upper plot that tells us what percentage of those folks voted for Trump. You can see that now the dots move in opposite directions depending on who is benefiting from the fraud. Here's dog catching. Notice that even though the outcome of the election isn't changing, our dots all end up plastered to either the right side or the left side of the graphs. That's the failure of the x-axis to do its job that we were talking about earlier. And finally, here's a feature map for plots that omit the minus x term. There are a few points out of place in Oakland County's absentee data, but not nearly enough to form a pattern. Trying to apply our map won't get us very far. Those few out-of-place points could be nothing more than statistical variance. The best you can do with a map in a situation like this is to find a starting point for further investigation. For instance, in Madison Heights' 6th precinct, there's nothing above and to the left of the purple dot, and nothing below or to the right of the green dot. That implies, but it isn't certain, that the purple dot shifted up and the green dot shifted down, and perhaps they got shifted to the right. Looking at the map, that combination could be explained by some of Biden's votes not getting counted. It could be explained by, for instance, a batch of mail-in ballots from a single all-Democrat neighborhood being lost by USPS. It's possible the other three dots could be explained the same way, since green dots below 50% shift down in that case, while green dots above 50% shift up. It's not the only possible explanation, but it is one that makes sense. How about Oakland County's in-person data? This is the data that had such a bad R-squared fit and where we saw so many green dots out of place. I've marked what I think are the outliers in red so we can see them in both datasets at the same time. If these are in fact the true outliers, we can see that the purple dots shifted up while the green dots shifted down. The pattern is erratic, but interestingly, these outliers are good for Trump. The one pattern that could potentially fit here is, again, some of Biden's votes not being counted. That's a very surprising possibility given the concerns of the Republican Party. But are we sure enough to scream out that Biden got cheated here? By now I hope you've realized that just because we don't get what we expect, it doesn't mean that fraud absolutely had to have occurred. I don't want to jump out there and shout, "Fraud! I found fraud!" Let's remember that splitting was high in the county and that we might be seeing x-axis failure. It's also super interesting that this showed up in the in-person data and not in the mail-in data when everyone was so concerned about the mail-in ballots. Because of the dataset, the pattern we're seeing only suggests that there are missing in-person Biden votes, not that those votes were missing altogether. Perhaps this strange data was caused by nothing more than Democrats choosing to mail in their ballots instead of voting in person. Most importantly, failure of the raw data to match our predictions is never a proof of fraud, only a justification to look into the data to find out what happened. But if it were my job to spot check election integrity in these counties, I would pick districts where the in-person voting rates fell way off the predicted plot line in Oakland County. We've almost reached the end of our journey. We've seen that almost all of the raw data Dr.SHIVA used was pretty well explained by our model. We saw that the -x term doesn't do its feature detection job, and we should probably just toss it out. We've seen that the plots can be deceptive because of high split ballot voting rates and dog-catching behavior. Along the way, I discovered that plotting the percent of split votes right alongside Dr.SHIVA's graph really helps a lot when trying to interpret raw data. We saw that specific line and parabola shapes really have nothing to do with predicting what's normal and what's not. And finally, it should be clear by now that Dr.SHIVA should never have used his initial results to claim that tens of thousands of votes were stolen from Trump in the 2020 election. At best, a proper analysis shows which districts should be investigated further. So, what could future researchers do better? The idea of using the x-axis as a measure of how conservative a district is seems to be a pretty good one, but a better data source is needed than just how many straight votes were cast. You might try integrating voter registration data or encoding each voter's registered party into their ballot in an unreadable way. Also, adding in more external data to the model, like past election behavior, polling data, or district populations, might lead to a model that doesn't end up with fraud features looking like non-fraud features. Finally, I want to say a brief word about Dr.SHIVA's second video and the plot he shares in it. That plot mixes data from both Democrats and Republicans on the y-axis in exactly the same way he did in the first video. I haven't done a full detailed analysis of that plot for it. As you can tell, it's quite a bit of work doing that. But once again, Dr.SHIVA claims, without any proof, that the width of the scattered data can tell you if fraud is present. But he's wrong. Because he plots votes on the y-axis, the more Republican a district becomes, the more crossover votes Biden will receive. Unlike all the other plots we looked at, the x-axis on this plot doesn't say anything about how Republican these districts are. Instead, I've taken the data and broken it up into 4 separate plots according to where they would fall on the x-axis in the other plots we looked at previously. At the top, the districts are heavily liberal. At the bottom, we have mostly conservatives. As you can see, Biden's plot starts out as a perfectly narrow line, just like Trump's does. Then, as the districts slowly become more conservative, the plots start to shift up because of Republican crossover votes. You can actually see the same thing happening for Trump, just not to as great an extent. In heavily conservative district, his plot is straight and narrow, and as the districts become more liberal, his line shifts upward and gets a little wider, as he receives crossover Democrat votes. He just has a lot less of them. Far from showing fraud, this plot only explains to us why Biden won, and it's a story we already knew. The width of Biden's plot only shows that he got a lot of crossover votes from Republicans, while the narrowness of Trump's line tells us he got few crossover votes from Democrats. Now we really are at an end. I'm not a statistician. I'm not a mathematician. I'm not an expert in elections. And frankly, I'd be flabbergasted if someone out there with a PhD hasn't done a far better job of researching election fraud detection than what I've done in this short video. But that's beside the point. Election integrity is important, and people shouldn't go around claiming they can prove fraud happened when they can't. And I don't want to see our country torn apart over false, disprovable narratives. Dr. Shiva's persistence in pushing his flawed election analysis theory in an environment that's so filled with hate is irresponsible, at best. I hope he continues his work toward making elections more transparent, but he needs to stop pretending that he's somehow proven this election was stolen from Trump. Thank you for your time.